My name is Michael Staib. I'm a GraphQL Technical Steering Committee member, and I'm the author of the Hot Chocolate GraphQL library in .NET. And today we are going to explore how we can get started with GraphQL and why GraphQL is awesome. Before we get started, let's do a quick temperature of the room. You can scan this barcode or QR code, and then we do a quick quiz. Awesome. Okay, let's start. So, who has used GraphQL before? Or who has just heard about it, or experimented with it, has it in production? I will unlock. Yeah, 50 users can go on. Awesome. That's good, because we are getting started. So, okay, let's see the next one. Now I took it away. Damn it. Mini mistake. Okay. So most people think it's 5 years, and that is, when I go to conferences, most people will exactly say it's 5 years old at .NET conferences. Okay. Actually, it was released in 2012, and initially they called it Supergraph, for lack of a better name. So in March 2012, Facebook released GraphQL into production. But it was only later open sourced. So GraphQL was open sourced in 2016. They announced that they will open source it in 2015. That's why most people think it's younger than it is. So GraphQL is quite mature at this moment in time. But let's explore what GraphQL really is, or why GraphQL was even created. So back in 2011, Facebook faced a big crisis with their mobile application. The mobile application actually didn't look so sleek like this. It more looked like this. And users hated it. Because when they started it, it was really slow, sluggish usage of it. And it used a ton of data. And back then, data was precious. Think about how much data capacity you had in your mobile phones around 2012, 2011. Maybe half a gigabyte, maybe a gigabyte, depends on your mobile provider. Today, we have unlimited, or in many cases, we have unlimited use of data in our mobile phones. On top of it, they found out that it really had a bad impact on your battery. Your device would get hot, and it would use, in a short amount of time, all your battery. So the Facebook engineers went and analyzed what went wrong with the mobile application of Facebook. And what they found out is that they done everything like they did with their web application, like with the Facebook web application. So they used HTML, they used REST as a backend, so everything seems to be fine. But when they looked at startup times and what the application actually did, they found out it first just fetched the user. And when they fetched the user from the REST endpoint, it would give them some data. The data that the developers of that endpoint actually intended for the desktop web application. So it sent down not 3 properties, but around 100 properties just for the user. But that was not it, because Facebook is nothing without its newsfeed. So it first fetched the user information and then just went on to fetch the news of this user. And again, not intended for mobile application use, it started to fetch the news with thousands of properties and thousands of items. But the news are actually not the fun thing. What else do we have at our news? It's likes, it's comments. And when we look at the comments, comments have authors, so we need another fetch to our user to fetch the author of these comments, and so on. And that is not because that was a bad application design or a bad service application design. It was that REST was designed around the concept of resources. So we wanted this isolation because it scales nice, and we have these nice buckets, like a user endpoint that deals with everything user, and so on and so forth. So we could optimize that with REST. We could now start and create mobile endpoints, or start with sparse fields or something like that. But we would invest a lot of work and a lot of new API to just solve now for every new device that we create the problems. So when Facebook looked at their data fetching graphs, they saw something like this, and we call that a data waterfall. These are consecutive data fetches, where we first get the user, but we cannot fetch the next request before we have the user data, because we need an ID that is hidden in that data that we don't need from the user request, and then we fetch the next thing, but we still have to wait for all the requests to resolve before we can fetch the very next thing. So we are kind of blocked, and this is why the Facebook application back then performed so bad. That is where 3 guys at Microsoft came up with a new data technology to fetch data or expose the domain layer of Facebook in a much better way. So in GraphQL, this is basically the hello world of GraphQL, we could ask for what we want. Essentially, GraphQL reverses the responsibility of what to fetch and empowers the consumer of our API to ask for exactly what he or she needs. So in this case, we want to have just the username of our service. And our GraphQL server would respond with exactly the requested data. But as our components change or our data needs, like we are moving from desktop to mobile, we have different data fetching needs, and maybe need some more data, maybe need the profile picture of that user. So we could just craft a new request for this new use case and ask for more data. And again, our server would just respond with the data we asked for. And if we look at that, we realize that GraphQL is not about flat data structures. It's about data trees. And that's why it's so great with GraphQL to explore connections, because I can drill into my friends maybe in the Facebook use case, and not only fetch the user, but in the same instance already all the friends of this user. I could go even further and fetch in the same request also the news and the comments that I need. And if we look at that, we can see that we are repeating things that we want to fetch. Me, for instance, is a user, and friends is a list of users. And in both cases, we are fetching name and last seen. So that's why Facebook actually introduced something we call a fragment. And a fragment is our primitive of composition in GraphQL. It allows us to compose fragment hierarchies as we compose component hierarchies in our front end or class hierarchies in our back ends. But more to that later. So GraphQL gives clients or consumers the power to ask for exactly what they want and nothing more. So what is GraphQL? GraphQL is a query language for your API and a runtime to fulfill those queries. And that means in GraphQL we have a single endpoint, and we can get all the data we need in a single request. And that means we don't have the problem of over or under fetching that we have with traditional data fetching technologies. Over fetching is every time an endpoint, like the user endpoint, gives us too much data, gives us data we don't need. We maybe just wanted the username, but we get all the information about the user. So that we call overfetching. Underfetching is the reverse problem. We fetch the news, and there is an author ID in there, but we don't want this ID. We actually want the name of the author. So we underfetched and have to do a consecutive data fetch to get the actual information we need. GraphQL is built on a strong type system because when Facebook looked at their API, they said, oh, we have an awesome domain model that we designed in our internal API. We want to make it expose, or we want to be able to expose it without compromise. And this type system, this strong type system in GraphQL, makes it very predictable to use the API from a consumer perspective. Because when GraphQL tells me that a field is a string or a non-nullable string, it will never violate that contract. On top of that, GraphQL is real time. But enough of the talk. Let's see some code. But before we see some code, let me say one last thing here. So in GraphQL, we have operations. And that's an important aspect to understand. We have three operation kinds. We have queries, that is side effect-free reads on our model on the backend. And then we have something we call a mutation, that are our write operations. And if you compare that to REST, it's the put, post, patch, delete that we have to figure out which verb we actually have to use in REST. And subscription is our real-time capability to query the system in real time when something is happening, so the events in our system. In this first demo, we will have a look at queries. So let's dive just in. Actually, let me get rid of this and then go in. So this is an empty project, or it's not even a project, it's just an empty folder. And what we're going to do is create a GraphQL server and see what we need to do to create a GraphQL server. So the first thing we should do is maybe just create a web server. So .NET New Web will just create an empty web project. It's done at ASP.NET Core. And if we look at that, there's not much to it, right? We have a program CS, we have a hello world here, we could run that, call this endpoint, it will say hello world. So these are the basics. So how do we make it a GraphQL server? So the first thing we need to do is add a package. And we are adding the hot chocolate.asp.NET Core package here. Did I miss? No, should be all right. Okay, that's adding now the hot chocolate GraphQL server for the net. Let's see if everything is in here. Okay, it's now in. And with that, we can build a GraphQL server. And I said that operations are important. And we are going to build a query operation. So that means let's create a query.cs. And this query.cs is a simple class that will represent our query type. So let me put just an empty class in here. So in order to expose something in my GraphQL server, and let's start with a simple hello world here, we need something that we call a resolver in GraphQL. A resolver is just a simple method in hot chocolate. So I'm just creating here a method called hello, which has an input, like an argument we would say in GraphQL, or a parameter in C#, that is called name, and has a default of world. And from that, we compose just a string here that says hello, name. Let's run that. So it's building. 2 seconds. And it's up. Let me just copy this URL. Let's paste it in here. That's not what we want. And that is correct because I forgot something. So we created a correct operation type here, but we set to our web server nothing how to deal with that. So in GraphQL, to make it a GraphQL server, we actually go here and look at our web application builder, and then we say builder.services.add GraphQL server, and then we add our query type as an operation to it. So we say add query type, query, and now we have a GraphQL server. But there's still one piece missing, and that is the transport. At the moment, we just have mapped this get endpoint here. And to make it a GraphQL server, we need to say map GraphQL, and then we're done. Let's rebuild that, and let's see if it's now a GraphQL server. I always struggle with the hot reload. No hot reload. Who actually wanted hot reload in .NET? Okay. Okay, and that's what I expect. So we get 404 because we don't have mapped this initial endpoint anymore. And the GraphQL endpoint by default is mapped on the GraphQL route. And if I go on this route, I am greeted here with banana cake pop. That is the GraphQL IDE that our open source project has built. And we can now dive into our API by creating a new document here. And it says, you want to create a new document for our API? I say yes. And then I could start writing my GraphQL query here. But before I do that, I can dive into my schema and look at what it exposes. And we can see that I'm exposing here the query type. And down here, I can see that the query type has a hello field. And this hello field has an argument name, which returns a string and has a default world. So why am I saying that? Because GraphQL exposes my internal API over the wire in a much richer way than I could do with REST. It doesn't work just with those simple cases, like if you have interfaces or things like that, it will also translate to GraphQL, and we will see that in a minute. But let's start with this simple thing here. We can just now write a GraphQL query and ask for the hello field. And if we run that, we get hello world. And since we have an argument, we can pass data in, like Michael. And then I get hello Michael. So that is nice. Let's make it more complex. Let's put some more data structures in here. For instance, let's add an author. Typical example, I know. And maybe a book. And the book has an author. And then we introduce a new resolver to our query type. And that is the getBooks resolver. And the getBooks resolver will return here 2 books of the same author. So let's go back to our GraphQL endpoint and refresh our schema. And let's have a look at that schema. We immediately can see that we now have a books field, and it's called books because in GraphQL we don't use these verbs like get and things like that. So we would also remove things like async, things that are .NET-y but not GraphQL-y. Okay, we also can have a look at it differently. Like this is our query type. We can now dive into our books field here, and then can dive into the author to fetch the name. Let's do that. So we fetch above here, hello still, but now we also want the books. And from the books, maybe just the title. And when we fetch that, we exactly get what we asked for. But we also can fetch like everything and go in and ask for the author as well. And the author doesn't have a title, but a name. Reformat that. Something is wrong. That is not right. Okay. And fetch that, and then I get what I asked for. Okay. That is awesome. Let me close that. And let's get back to the slides. So let's recap that. That was our query operation type. And the query operation type has something that we call in GraphQL a resolver. That's the C# method here. And when our GraphQL server looks at this class, it will translate it into a GraphQL type that looks like this. And in a GraphQL type, this, by the way, is the annotation-based approach. And when Facebook invented GraphQL, they started with the annotation-based approach. So essentially, you have an API. We infer from that the GraphQL types, put a thin layer of GraphQL on the top, and then essentially our domain model is exposed. So in the GraphQL type, hello is called a field. And a field in GraphQL is like a method in .NET. And then we have in our field arguments, like in a proper method. We don't have to have arguments, but we can have. And these arguments can have default values, like in .NET. But we even can have more here. We could have object trees as default values that we cannot have in .NET. And at the end here, you see always this bang operator, because in GraphQL we have the reverse. Types are nullable by default. And if we want to make them nullable, we apply the bang operator. This is a bit reversed from the .NET way. Like in .NET, we put a question mark at the end to mark it nullable. Okay. Let me say something about the transport. Because in GraphQL, we write this nice query. But how does it translate over the wire? So the typical GraphQL request is an HTTP POST request. So if you go and look, for instance, at Twitter, Twitter uses GraphQL, then you see only HTTP. And then it's GraphQL. GraphQL works over HTTP. By the spec, GraphQL is actually transport agnostic. That is why you also can use WebSockets to use GraphQL, gRPC, or server-side events. Works also over these. So let's make it more complex and build a more complex backend. And we have, let me go through that. We have built a little demo application with which we teach GraphQL. That is this crypto application here where you can check crypto prices. The prices are not real, so don't buy. So this application is what I call a modern application. What is a modern application? And this is like a fancy term, but for me a modern application is reactive. And that means if I, for instance, go into here, the data really lives. That often translate into me using observables. You can see the prices changing. But if I go back into my dashboard view, the prices in the ticker will change whenever something changes in the backend. By the way, this real-time data is GraphQL over WebSockets, so this doesn't work over HTTP. All the simple data fetching is done over HTTP. But let's have a look at the network tab, and it's pretty small. But you can see here 2 GraphQL requests because I navigated essentially to the Bitcoin price. Let's kill that. Refresh the app. So the internet is really not so nice here. I struggled yesterday with it, but okay. But what you can see is that we have a single GraphQL request to get all the data for our components. And if I go now to the Bitcoin price or to any other price, let's go to this one, we have, again, just one more GraphQL request because we can fetch everything we need at any point in time in one request. And that makes it super resilient over mobile connections. Like you're on a bus, you have a 3G connection, you fetch something, it's not 10,000 connections that wait for other connections to finish. It's a single connection to fetch your data. Okay, let's have a look at how we could build such a backend. And let me go back to the slides here. So just recap. So a goal for our modern application that we want to build is that we want to have a fast iteration. We don't want to block our front-end engineer of building the front end, meaning he should not wait for us in the back end to create a new REST endpoint, so just that he can finish his use case. He should just tell the back end what he needs, or he or she needs. And we want to have strong contracts. And you saw how the .NET API easily translates to GraphQL. In GraphQL, we actually have more type constructs than in .NET. Because in GraphQL, we have, for instance, unions. We don't have that in .NET even. And on top of that, modern applications should enable me in development time that I'm really work with static typing. And GraphQL is statically typed. And that translates to me in React, when I compile my React application, I get proper compilation errors if I ask for the wrong things. Okay, let's go and have a look at the next demo. And that is, how would I deal with proper data? And typically, a lot of .NET engineers still love entity framework. So let's have a look at how I could expose something that is in my entity framework. And in this demo, okay, let me click that away. I have just a DB context, and this DB context provides the base data for the API we saw. So we have an asset, that is essentially my coin here, and I have information about the asset, and I have the asset context, which is my DB context here, and I have the asset prices. Okay, so how could we make that a GraphQL server? So what we learned in our first demo is that we need to create an operation type here. So we could start again with the query type that we built before. So empty class, query. So how do we expose our entity framework data here? That's quite easy. We learned it's just a method. So we could create a method called assets, get assets, that returns an iQueryable from our DB context. There's one thing in GraphQL. We want to parallelize data fetching so we can fetch data really quickly. And that's why we used method dependency injection, meaning we are not creating all the services that we need for all the resolvers at once. We are looking what your request looks like, and then we only create the services for the resolvers you really need. So we are injecting here the asset DB context, and then we are just returning the assets. Okay, let's set that up in our server. We already have the add GraphQL server here. To host our query type, we just do add query type and then query. That's what we did before, right? Let me just reformat that. So what you can see, I'm using a pooled DB context up there. And I'm using a pooled DB context because I want a fast server. I don't want to waste memory of a scope DB context, so I'm pooling it. And that also allows me to use multiple DB contexts in parallel. So I need to explain kind of to my GraphQL engine how to deal with that. So I can say register DB context, the asset DB context, and this DB context actually is a pooled DB context. It's not scoped. And now my GraphQL engine knows that it has to get the DB context from the DB context factory, use it, and then return it to the pool. I don't deal with this complicated stuff. I just tell my GraphQL engine about it. Okay, let's just .NET watch, and this time, no hot reload. This should be a default. Okay, let's wait for it to compile. And there it is. Let's go back to our browser here. It's now on port 5000 GraphQL. And let's refetch my GraphQL schema. Let's have a look at the schema reference, and I can see I have an assets field here, and I have all these property of my asset, and I have my asset price here. So let's query that. So I again start with my GraphQL query, give me assets. Maybe let's just fetch the asset names. And then I fetch that, and I get all the data. But this also introduced kind of a problem here because it's my whole database. And if I had more in there, that would be really a problem. And this is the right time to talk about pagination, because when Facebook created GraphQL, they also rethought how to do pagination. So typically when we talk about pagination, you would talk about offset pagination. And that's the skip and take what you do. But Facebook, with a lot of new data that is coming in by users all the time, had a problem with this skip take approach. Because when you maybe were on page 1 and you wanted to skip to page 2, and now new data comes in and you go to page 2, you again had the same data. Because we are not pinned to our items. And it could also happen that you have the exact same data because it's so much data came in that you maybe even went backwards by going forwards. So they introduced something that they call cursor-based pagination. And cursor-based pagination pins the item with a key. So it takes your ID of the entity and essentially navigates from that ID. So in cursor-based pagination, we would say we take 5 items after the ID 5, the item with the ID 5. And as new data comes in, our pages actually move. So we don't get repeated data. So what do I have to do cursor-based pagination? Sounds complex. So actually, we just say use paging. And that will recompile. Was more about the concept than. And now I can refresh here my GraphQL schema and I see, okay, there's something wrong. Schema has changed because we now have a type that they call a connection. So every list, they essentially say that's a connection to a different node in my graph. And you can see I have edges. Edges are essentially my asset and a cursor to that asset. And I also have nodes, which is kind of a clean view at my list. And I have paging info, where I have the end cursor of a page, the start cursor or the indicator if there's more data. Let's try that out a bit. So we could say nodes, and then I just again want the name here. And I fire that, and then I only get 10 items because that's the default we have configured in Hot Chocolate. 10 items by default, you can change that default. Okay, and I also can kind of look at the paging info. I just want to do a fast forward paging here. So let's just ask for, does it have a next page? And what is the end cursor? And if I ask for that, it will say it has a next page, and this is the end cursor. And then I can use like the arguments in my field, what my paging middleware just injected into that field. I want after the cursor, this guy here, I want the first 2 items. And if I do that, I just get the next 2 items navigated from the last item in my list. Okay, let's just wipe that out. Go back to our slides. Okay, and I said use pagination is actually a field middleware. What does a field middleware mean? So this is my resolver. And this guy up here is my field middleware. And the field middleware is the exact same thing that we have in ASP.NET Core, just on the request. So in ASP.NET Core, we would say use authentication, use WebSockets. And if we put them one after the other, it builds a pipeline. And that's the same thing that we do here. By putting use paging on the top, we compile from that a pipeline for this field where use paging is actually the first item in the pipeline, and after that comes the resolver. We have more of these middlewares, like we could say use paging, use projection, use filtering, use sorting, which add new data capabilities to your GraphQL resolver. So a field middleware works like this. I said it's a pipeline. The use paging middleware essentially asks for the next pipeline element in the list of the pipeline. And then get assets will be executed, which returns a queryable. And then use paging will apply on this queryable slicing. And if we add all the other middlewares here, then we can see, so use pagination differs to the next, filtering differs to the next, sorting differs to the next. Then we return the filtering, we create an expression for sorting, we apply that on our queryable, and so on. And at the end, this is translated into SQL, in the case of Entity Framework. This GraphQL query translates into the SQL representation. But actually, GraphQL is not a query language for your database. SQL is much better. But this is just the capabilities we can do with field middlewares. Actually, GraphQL is best on top of your application layer. So if you have a proper domain layer, expose this. Paging will work also with this. You can have a custom paging provider for your domain layer. But let's have a look at the data middlewares first. Okay, so I said we can pipeline that here. So we can say use projection. And then we can say use filtering. And then we can say use sorting. So that's our pipeline now. This guy belongs to the GraphQL core because it's a core functionality. These guys are integration for database provider, and we actually integrate with everything that is there. So if you bring us a MongoDB, it works. If you go with Cosmos DB, it works. If you go with Entity Framework, everything under there, it works. And we are also working on Elastic as a search provider on top. Okay, because these are data middlewares, we need to kind of tell our GraphQL server that we want to use projections here, and we want to use filtering. So we centrally tell our GraphQL engine that we are now using these data middlewares. Okay, should rebuild. No, I stopped it. That was not good. Just a second. Thank you. Okay, let's refresh that. We have a new schema. Let's have a quick look at it. If we now look at our arguments of our field, we can see we have the paging arguments, but we also here have now a where argument on order argument. So I kind of can now say, give me all the assets, and I want the asset name, and I want the price, and from the price I want the latest price. But actually, order this stuff, please, by the price. I use the price information, and then by the market cap. So the market capitalization of the coin. So I want the coin with the highest market capitalization at the top. So we are ordering it descendingly. Let's do that. And I get it exactly like I want. So I can empower the client to ask for the data and also tell my backend how I want this data. And let's have a quick look at, no, that's the other one, this guy here. Look at this. It's exactly the data I asked for, translated to the exact database query language. And it works actually with Mongo even better than with a native MongoDB driver. Okay. So let's go back to my slides. And one warning here. So actually, I wouldn't expose it like that, just expose my database. So as I said, use your domain layer, use your application layer. And if you expose filtering like that, tell the GraphQL engine what you want to expose here. So I would limit that. I don't have the time to show you, but you can actually create a little GraphQL type and tell it what filtering is allowed, because we don't want to have maybe text search filters on our SQL database. Okay. Let's talk about different kinds of data. Let's talk about REST. Because when you integrate GraphQL, and that's how it actually started, is that you might have other services. You might have a REST infrastructure, or you might have a gRPC infrastructure with lots of microservices. So what we talked about was GraphQL on the data layer so far. But actually, GraphQL would go on the business layer. That's how Facebook intended it. But when they released GraphQL to the public, it was used more like that, because people had their existing infrastructures with microservices or domain services, and they would use GraphQL to make it easier to work with their microservice infrastructure. So they would put it on top of that. And that can be in different ways. Like, I could have a part of that as internal data structures. I could use like the DB context as an internal data, and then merge that with data from other microservices. For instance, in our example here, we will have a price change service that lives in the cloud as an Azure function and provides aggregated data functionality, so like the percentage change that a coin does in a specified amount of time. So our REST service has a URL like this. You can call it. It's actually online. You can't, because I didn't post a real URL. Okay. So our service would return a data structure like this. Like, when I asked for the Bitcoin for the monthly change, I would get a percentage change here, like 0.1%, for instance. And I want to integrate that into my GraphQL service. So how would I do that? Let's just wipe out my other demos here, so we don't get confused. And let's start with demo 3. Okay, that's the same service that we saw before. So I have my AssetDB context here, but it's a couple of iterations further. So I maybe have now account types like users and stuff like that. And I now want to integrate that with data from my REST endpoint or from my microservices. So how could I do that in the case of REST? So REST is unstructured data. Okay, it could have a Swagger schema or so on, but mine is just unstructured data. So GraphQL has something that they call the data definition language, or the GraphQL SDL, and I can use that to describe the unstructured data that I have there. So I could say schema.graphql, and then I could add a type here, and that was a type I showed you earlier. I could just say there's an asset price change type in the cloud, and it's a JSON object, and grab this field here from that JSON, and it's actually a float. So now I type this data structure that I have somewhere there. I ignored the fields that I don't want from it, and then I could integrate that into my GraphQL schema. And that's very easy. I tell my GraphQL engine that I actually want JSON support. And then I kind of say add document from file. And then I take the schema.graphql. Okay. And there's one more thing. So I now have a type. I maybe have this this price node type here. And you can see that it already has a resolver here. And I'm just adding another resolver. And this resolver fetches essentially with an HTTP client just from this REST service and returns essentially the JSON element. I'm telling it this is actually the price change type that I described. So let's see how that performs. No, hot reload. Okay, let's wait for it. Okay, let's go back to our schema here. Let's refresh that. Let's have a look at our schema. So we have here query. I said it's a couple of iterations further, so we have more resolvers here. So I can drill into my asset here, and I can drill into my price here, and then I have my price change type here. So I can ask for the price change, like the time span. You can see this in enum. to ask for my service, and then I get back this price change field. And let's do that. So I have this field here, and then let's ask for the change of each currency over the months, and then ask for the price change. Let's execute that. The specified argument is not right. Why is it not right? Because of... And you see, so the GraphQL client here doesn't even allow me to call that. But wait a minute. This seems slow. 8 seconds. That's bad. That's the time to talk about data loader. So Facebook actually introduced this tool data loader for the REST API originally. And data loader are an integral tool in the GraphQL toolchain. So we just integrated a REST endpoint. What happens when we integrate a resolver that naively? So every time we have this change method here, we will execute it. If we have a list of 10 items, we will 10 times go to this REST service and ask for it. And a data loader doesn't just help with HTTP requests, it actually could also help with fetch requests to other databases. So what we would do here is create a new component, we call it the data loader, put it in between our resolver and our fetch request. And what happens here is when our resolver will ask our data loader to fetch for our cryptocurrency the price change from that REST service, we would ask the task cache of the data loader, kind of a promise cache, to give us a promise for this data. If it doesn't have a promise for this data in its cache, it will create a new one, and then we would wait for the data. So when the execution engine has executed all the resolvers in our pipeline, it would batch all the requests to that endpoint in one go. So for this, our REST endpoint actually needs a batchable endpoint. In this case, I created that so I can ask for multiple symbols at once. And the data loader improves data fetching and ensures consistency in one request. So let's have a look at how that looks. So at the moment, our resolver actually looks pretty complicated. If we offload this complexity to our data loader, it actually looks like this. We ask for the asset price change data loader, which essentially fetches here again the data from that endpoint, but then fetches like multiple things at once, and then just returns a collection of JSON objects. And our execution engine will then fulfill for each resolver the data. So let's see how that performs. It actually is already, I shouldn't have saved. 10 minutes. Okay, let's go back to here. Let's just execute it again. So the first fetch always is slow because we build up the schema, but you can see now we are at 112 milliseconds, although we fetch a lot of data from our REST endpoint. That is a concept in GraphQL we call a data loader. Okay, so we did that. Let's talk about one more aspect, and that is real-time data. We have 10 minutes, let's do it. So when we talk about real-time data, we are calling about streams of real-time data. So instead of having a single GraphQL response, we have a stream of GraphQL responses. And that actually translates very well to async enumerables in .NET. So when we talk about subscriptions, we are talking about events, an event stream, and we are talking about a response stream. And how that works is when an event is triggered, we will execute a GraphQL query and send that down to our consumer. So let me quickly switch over demo 4. Okay, so this is again the same server, just the next iteration phase of it. So, and here we have the asset types that we are using. And what we want to do is essentially implement a new event. When the price is changed, we want to get a price query down to our client. That is, when you remember our UI in the beginning where the price changed, that was a subscription. So let's add first our class here. That is an asset subscription type in this case. It's a root type, like query, and we can add resolvers to it. But I said subscription is about a stream. So we first need to create an event stream. And again, I said an event stream actually translates well to an async enumerable. That is an awaitable stream. And this awaitable stream you can hook up to anything, to any event system like Redis or whatever, and yield events from there. So in this instance, I have a price change service. That's an internal service that triggers us an event and tells us which price has changed and yields, in that case, the symbol of the price that changed. The second component we need is a resolver. And that is the same resolver than we did for our query. So this resolver is called onPriceChange here, and it gets injected an event message that is the symbol from this event stream whenever it occurs. And then we use a data loader here, this time for our database, to load this data efficiently. So the one thing we have to do is tell our resolver that it actually subscribes with the event stream that we have defined up here. So let's put that in, and then let's just check that I have set up everything right, because I also need to register. Let me just check if we have done that. Subscription type here, add subscription type, and let's run that. .NET watch, no hot. I should copy paste that next talk. So it's starting. Okay. It's coming up. So you can see it's a lot more happening here because we have real-time data. Actually, we are emulating here price changes. So that's why we are updating constantly the database pushed by a backend service. Let's refetch here our GraphQL schema. It actually says, oh no, okay, it's not ready to be fetched from. I hope it comes up. That is always not ready. Okay, that doesn't matter. I have prepared for that use case. So we have a little endpoint here. Let me just get that. Workshop. Is it this one? Import batch. Let me check. No, that's a local one. Yeah, this one. So let's just say API. And go. No. API-cc. 1 second. Would be a shame. It's always subscriptions. Workshop, no, that's the other one. One second, let me copy that. It went so well and now it's dying. Oh yes, sorry. It's API/crypto dash workshop .chillicream.com/GraphQL. Okay, so here we are. So this is the same service that I wanted to have in the end. We don't have time to figure out why it's broken. But essentially what we have there is now a third type, the subscription type. And then we have the onPriceChange event here, And it's the same data structure that we actually have in our query. So what I can do now is here write a subscription query. And what is awesome for the consumer of this API, that the only thing he or she has to change is writing here subscription, and then we can drill the same way into our data like we did before. Just come on. So we can say on price change, that is our event here, and then we can drill into this, like latest price, or maybe we want something from the asset, and from the asset maybe we want the name. Let me just reformat that, and then we can just execute that, and nothing happens. And that is because we are subscribed. And there will only something happen when the backend has some events. And I hope this backend has some events at any point there. They're coming in. So every time when the price changes in the backend, it will execute our query and send us these responses. You can see it's sometimes pausing because not always are these cryptocurrencies changing. And that means sometimes I get a bunch of events and sometimes nothing. So, and let me just conclude that here. And that's also what you have to think about when implementing subscription. You have to think about throttling maybe. You don't want to send the client too many events. Otherwise you're frying the mobile device or the desktop. So we have to think about throttling, also about quality of service, meaning is this event like important? Maybe we need a replay functionality. We can do that in our async stream, like fetch the missed events from the database and first deal them and then start real time. Multiplexing is actually solved by the GraphQL WS protocol, but still you have to think about these things. Okay, unfortunately, we don't have time for this, so let me jump to my conclusion. So GraphQL is evolving rapidly over the last 10 years. Think about it, 10 years ago, Facebook started with GraphQL, and when they open sourced it in 2015, they talked about it. They said, okay, we have something cool, and we are running it in production for the last 4 years at a scale of 500 million users that do a ton of requests. I think it was 20 billion a day. So I'm not sure anymore. But GraphQL is tested at massive scale. It's not a thing that nobody uses. Like if you think about the users of GraphQL, we have GitHub, we have Microsoft. Microsoft Teams runs on GraphQL. Microsoft Office runs on GraphQL. Then we have Twitter, Netflix, all GraphQL. So GraphQL is running the internet companies of the current age. With that, I'm done. This is all open source. You can go to our GitHub repository. If you like it, please give us a star. If not, doesn't matter. If you want to follow me, you can copy the page and get into contact with us. And with that, I'm done.